Hey there, folks. So this is Chapter 8, Question 20. And this one's kind of an interesting question because this is how they give you the initial substrate, and then they ask you to do the E2 reaction with it, with an alkoxide. And so you'll notice here that when you do this reaction, you actually have two stereocenters right next to each other. And it very much matters how exactly those stereocenters are oriented versus each other in this reaction. So for example, if the hydrogen was opposite of the chlorine here, or if the methyl is opposite of the chlorine here, that's going to give you very different products. It's also going to give you a bit of a different reaction that you can do in terms of the attack. And so what this question actually asks you to do is two parts, of course. You have first, the first part that you actually have to do anything is the mechanism, but that mechanism step actually requires almost a sub-step, if you will. You have to figure out the geometry of this, and you have to actually spin it so you can do the attack properly. Okay, let me go ahead and show you the structure for that. Okay. Now I'm going to warn, this is one place where this drawing computer system is rather temperamental. And so you really need to be careful when you draw these things, and you may have to just delete everything, all the bonds around a stereocenter, and put them completely new in, just brand new, fade away this way, fade towards you this way, in plane that way. And that has to do with it triggering, and like if you're just on the line here, which side is that? Hard for the computer to tell. And every now and then it gets those triggers stuck, I think, or something goes on there, and it does not work properly. And yeah, it's a mess. But it's fairly easy to fix by just deleting all the groups that are bonded to the stereocenter and re-implementing their directionality to them. It seems to always work. And if they do it with intention, because they know basically what the answer should be, then it always works. It never has any issue. It's only when you try to move things around a bunch that causes chaos. Okay, so in this problem here, don't forget that our original structure, the chlorine and this methyl, were actually different directions. But this is a single bond. You can rotate freely around the single bond here. And so we can actually rotate this to have a slightly different geometry. Stereocenters are still completely the same. We're just rotating around that bond. And you can do this really easy with a model, or you can do this with any three-dimensional objects you can use that have stereospecificity, like your hands, of course, are chiral, so you can do this with your hands quite easily. And so what we're seeing here is we're going to go ahead and rotate this. And notice that now we're going to rotate it in such a way that this chlorine, instead of coming out away from us, is actually going to come towards us. Now that means the stereocenter needs to rotate the whole thing. And what that means is we're going to push this an increment towards us, and so everything else gets pushed an increment different. And so notice this bond here was in the plane. It's now going to be into the plane. The hydrogen that was out towards you is now going to be in the plane. And then that chloride that was away from you is now going to be towards you. Just as if you'd taken like a fidget spinner and spun it just like a third of a cycle. Okay, that's what we did here. We spun that fidget a third of a cycle. And that gave us this geometry on this side. This geometry on this side does not actually have to do any different. The reason we have to do that is we actually need the chloride here, which is the leaving group, to leave from the opposite side of the hydrogen that's being attacked. And that's because the electrons have to actually flow in this direction. And so this is actually kind of an unusual case because normally we don't really have to worry about this as much in terms of the end product, due to the fact that we normally don't have a lot of stereocenters right next to each other, but in this case we do. So we have the alkoxide. It attacks the hydrogen here. This is going to leave the electrons into what will be the double bond later, and then the chloride is going to leave. Now note that this actually sets the geometry for this double bond, which will then trap that geometry into your EZ configuration. And so if you look very closely here, what you have to remember is we're having this chlorine leave from up towards us. The hydrogen is then going to develop. The hydrogen is getting taken here from away from us. So what you can notice here is this methyl right here is opposite to this group right here, the benzene ring. And so when you actually make your double bond, notice again the methyl and the benzene ring, they have to be opposite to each other, because that's actually the orientation in your mechanism reaction. That's what causes that. Okay. I think I covered everything you need to know about this. Let me know if you have any questions or if there's any issues. I think I got it all. Yeah. This is probably the most difficult part right here. If you have a model kit, this is actually quite trivial because you can actually put different groups on here and spin it. The other way you can go about this is you could actually make, if you've ever seen those things that little girls use to go, I will be my future partner, blah, blah, blah. And then like they spin the two sides versus each other. It's very similar to that actually as well. So if you make a three-dimensional object that has three different parts to it and then spin it one increment, you can actually use that to really help yourself keep track of this geometry. Full disclosure, I don't really have any issues keeping track of this in my head, but if you do have issues keeping track of it in your head, again, take a object that can spin around one focal point that has three essentially propellers on it, and then you just need to spin that one increment. And what you'll see is that all of the increments change, just like I'm showing right here, which is one increment towards, back, in plane. Okay. I think that does it. Take care now.